Chapter 3, Solving Inequalities. We're going to work on sections 1, 2, and 3 together. Inequalities and their graphs, inequalities using addition and subtraction, and using multiplication and division. So these are like the 1 and 2 steps, equations that we did back in chapter 2. But while we solve them, I'm also going to show you how to graph them on the number line, because we're just working with one variable, so we work on the number line. So looking at the first example, x plus 4 is less than 7. Remember, this is less than, looks like an L. So if we had an equation here, to get x by itself, we would subtract 4 from both sides. It's the same thing in inequalities. The 4's cancel out, you're left with x is less than 3. When it's just less than, not equal to, it gets an open circle. So at positive 3 on the number line, we're going to write an open circle, and less than means the arrow goes to the left. Now you can draw it on the number line, you could draw it above the number line, as long as it's over the 3. The next example, again, we're going to subtract 4 from both sides, but this time we get x is greater than 3. So it would be an open circle at 3. Greater than means you're going to the right towards the positive numbers. Next example, again, when you're adding, the opposite is subtracting, but now it's x is less than or equal to 3. So that would be a closed circle, so you color the circle in at 3, and it's less than, so it goes to the left. And finally, the last one, same inverse operation. You subtract 4 from both sides. You get that x is greater than or equal to 3. Closed circle at 3. Greater than means it goes to the right. You should have a separate number line for each of these examples. It doesn't have to be a big number line. You can just have 2, 3, 4, and arrows on either side. But you should have a separate number line just so it doesn't get too messy. The same goes for the next examples. So here we have 4 examples. Again, they're all using the same function. They're all using subtraction, and it's a simple one-step inequality. To solve the first, we're going to add 4 to both sides. That gives us that x is less than 9. So on the number line, we go to 9. It's just less than, so it's an open circle. Using a straight edge, draw an arrow going to the left. Next example, again we add 4. It's the same inverse operation, but x is greater than 9. Open circle, arrow going to the right. Next example, separate number line. Less than or equal to 9 means you fill in the circle because it's or equal to, and it goes to the left. And finally, add 4. You get that x is greater than or equal to 9. Closed circle, arrow going to the right. Now we move into section 3, so solving inequalities using multiplication and division. So these are like 2-step inequalities. For the first example, we're going to isolate x. We want to get x by itself. We're going to start by subtracting 4 from both sides. So now we have 3x is less than 3. Then we're multiplying by 3, so we're going to divide both sides by 3. You get that x is less than 1. Just less than means it's an open circle. Less than means the arrow goes to the left. Here, same operations, same inverse operations, but this time we get 3x is greater than 3, which means that x is greater than 1. Open circle, because it's not equal to, arrow going to the right. Same inverse operations for the third example. 3x is less than or equal to 3, which means that x is less than or equal to 1. It's or equal to, so it's closed, and it's less than, so it goes to the left. And finally, our last example, same inverse operations. 3x is greater than or equal to 3, which means x is greater than or equal to 1. So closed circle at 1, arrow going to the right. Now working with division. So we're going to start, again, get x by itself. So we're going to subtract 4 from both sides. You get x divided by 3 is less than 3. You're dividing by 3, the opposite is multiplying by 3. So you get that x is less than 9. Just less than means open circle, arrow going to the left. Same inverse operations here. X over 3 is greater than 3. Multiply by 3 on both sides. You get that x is greater than 9. Open circle at 9, arrow going to the right. Again, we have the same inverse operations for the third example. We're going to multiply both sides by 3. We get that x is less than or equal to 9. Closed circle, arrow goes to the left. And finally, x over 3 is greater than or equal to 3, which means that x is greater than or equal to 9. So closed circle at 9, and it goes to the right. Keep in mind that if you're drawing a number line in your book, it doesn't have to be from -10 to +10. You could draw 9 in the middle, show 10 and 11, 8, and 7 in the opposite direction. So just to review, less than looks like an L. When it's just less than, not equal to, it gets an open circle, and the arrow goes to the left on the number line towards the negatives. Less than or equal to gets a closed circle because it's including the number, and the arrow goes to the left. Greater than open circle because it's not equal to and going to the right, and then greater than or equal to closed circle because it's including the number, arrow going to the right. Finally, on a number line, if you were to start at 0, to the left, the numbers get increasingly smaller. So -1, -2, -3. To the right, the numbers get larger. So to the right, it's going towards positive infinity. To the left, it's going towards negative infinity. But if, let's say, you had a number that you were trying to plot on a number line, and it was x is less than 397, you don't have to start with 0 in the middle. You can put 397 in the middle, show 2 numbers up, and 2 numbers down. Same thing if you have fractions. Let's say x is less than a half. You can show 0, 1, 2, 3, and that x is less than a half would be in between 0 and 1 and going to the left. Finally, one really important thing to remember when solving inequalities, if you're ever multiplying by a negative number, when you divide both sides by that negative number to get x by itself, since you're changing the sign on this side of the inequality, you have to flip the sign that's in the middle. So it was less than, but then you divided by a negative, so the sign flips to greater than. The same thing works for division. If you're dividing by a negative number, and to get rid of it, to get x by itself, you multiply by a negative on both sides, the sign has to flip because you're changing the sign of your solution set. However, if you have a negative number already on the other side and you divide by a positive, the sign does not change just because that number was already negative. The sign only changes when you start with a positive and it changes to a negative, or if you start with a negative and it changes to a positive. So when you're the one dividing by a negative number or multiplying by a negative number, the sign has to flip in the middle.